This is the tailstock. It's fairly easy to disassemble once you know how. There are two screws located under here, and you'll see a slot that appears here, which is quite unusual, and you wonder why that's there. So if I first take this off, and then take this nut off the end here, and I can undo these two nuts now, these two screws. You would expect the end of the two screws to be sitting in the recess that's along there, but actually that doesn't happen to be the case. And there you'll find a funny shape, and there's a reason for that. Right, now pull this right out. We can see that there is a block in here with a thread on it, and as you turn the handle at the back, that moves up and down. And then, as well as that, it's worth pointing out, there's a stopper here, so there's an eject mechanism on the Morse taper, which is helpful. So when you put the screws back in, they have to sit in these holes but without screwing into them. And there's a little pin on here that engages with a slot on the back of there. And once you know all that, it's relatively straightforward. So the way I do it is just to look through the holes, which are quite a decent size, because I enlarge them very slightly. There. Put these screws back in. This is the headstock for the lathe, and I've had a pleasant surprise here. The bearings turned out to be even better than I thought. They're glass hard bearings, which was the fashion in the period for the best lathes in 1900 or thereabouts. So that's one bearing. And the other bearing is on the shaft. I'll just take that out of there. That's the bearing. There isn't a mark on it. Absolutely perfect. And this one I just haven't polished up, but it's not got a mark on it. And they fit into hardened steel, so it's hard steel onto hard steel, which, provided there's oil lubrication, is as good a bearing surface as you can get. And they float on a very thin film of oil because they're accurately machined. And these are really for high speed spindles, so this lathe should be able to take quite high speeds. And the carriers here for the bearings, or what do you call them, the outside part of the bearings, the shells, are pressed in, so I'm not going to take those out. And this one here is part of the shaft, and I found these very difficult to get off because they're a very tight fit on the shaft. So there's a keyway here, and there's one little pin which you can just see there, underneath there, and you have to line that up when you press it on. But you can see that's not going to go on easily, and they need to be pressed on and pressed off. There's no good hitting it with a hammer because you'll just damage the shaft. And then on the outside of the bearing, to protect this, there's a brass knurled retainer, and on the outside of that there's the gear. I've forgotten that. That's the adjuster for the bearing that goes on the shaft there, and that has the same arrangement with a screwdriver in it to open the slot up and aid turning it. But as you can see, that's quite tight when it's on, so it's never going to come loose. So those bits go at that end, that goes there, and then in the middle, that face goes up against the bearing on the inside. Then there's this fibre washer, and then there's another of these rings which is threaded with a slit in it. A little bit awkward to get to because it's hidden away inside the pulley. Again, you need to have a screwdriver ready for that. And this is the pulley, and as you can see, it has a ring of holes drilled round and a second inner one, and they match up with these two positions here where there should be plungers to index with. And the pulley is secured. It's quite a sliding fit, I suppose you'd say. So that gets secured with that hole there, when that's fitted in. I shan't labour this much longer, but I'll just give you a chance to have a look at the bearing surfaces again. I just still can hardly believe it. This is going to be the best headstock of any lathe I've got, I think. I think I can probably improve on the Oilers, which are just an open feed line that goes in, nothing else. But they won't need much oil because the bearing fits will be so tight. This is a threading attachment, which I've now cleaned up the casting for. Cleaned up the gears. The gears are absolutely thick with grease, and everything turns nicely as expected. Just quickly disassemble it. This comes with came with the compound gear for imperial thread cutting, but I will want a metric conversion, which is 127 and 50 tooth. These gear teeth are very small. They're 30 dp, 14.5 inch pressure angle, and I've managed to locate a cutter so I can make up extra gears. And they all fit together on this dovetail slide. This is an idler gear. And at the bottom of here there's a gear wheel, and there's two bearings in this little shaft here. This is quite interesting. And again they use the split rings, which quite easy to undo. You just put a screwdriver in to open up the gap a little bit, and they lock down quite well when they've not got a screwdriver in, just to open them up a touch. I suppose the alternative is to knock a little wedge in. And that's the start of the surprise, which is a cone bearing in this end and another cone bearing at the other end. So that's really quite nice. Now unfortunately with this, somebody has cut the shaft short, although it's got a centre drilled in the end of it. I don't suppose that's the original one, and this shaft is quite a bit shorter than it should be. So I'm going to have to make up a new one. This little bearing is quite interesting. Quite a simple looking little thing. When you undo this screw at the bottom, which holds it in place, again rather to my surprise, took that out, and it's got a cone bearing in it. So this is really quite unusual. Very beautifully made. I mean, the cost of doing all this must be phenomenal. It's worth just giving a plug for the manual, which I've got from lathe.co.uk from Tony Griffiths. It goes through various of the Sloan and Chace pieces of equipment, including the mill, but it does do rather helpfully some information on the screw cutting attachment, with a list of all the threads that can be cut. And it says on the instructions here that it can be as coarse as 10 threads per inch and as fine as 300. And it can also be done in metric. So I think I'm hopeful this should be able to cut quite a lot of threads. I'm missing the great stack of gears that come with the lathe when it's first supplied. So I shall have to cut extra gears, but I don't think that's a problem. I've bought a cutter, so I can make those reasonably easily. The main screw cutting attachment is held in place with this pull down bolt, and this goes up and is given half a twist underneath the lathe bed, and then that's screwed on the top to hold it in place. Nice and simple, works well. Now this is interesting, and I'll show you how. First of all, take the nut off. The nut is just held in with a simple bolt, and it does have 3 adjustable screws, so that you can alter the amount of angle. And I'll just move this so you can see what's happening. There is movement in the top slide, and if I look underneath, you'll see that there's a second dovetail. And that second dovetail is held in place with these 2 screws and 2 long springs that sit underneath it. So that's the first clue that there's something interesting in here. So if I just take this top slide off, Not scraped in the same way that the cross slide was done. You can see the machining marks, the original machining marks in there, and machining marks in there. Still traces of grease in here, which I haven't cleaned off yet. The whole thing was gunked up with 100-year-old grease and didn't move at all. It's absolutely locked in place. Again, you can see the scraping marks on the top of here, but just machining marks in there. So this is definitely not made to the same standard as the cross slide is. I'll just take the screw. There we are. And this piece is free to move. And behind the back of here are two plates which can be adjusted so that this controls the amount of taper that's cut by adjusting the screws on the back of here. Very difficult to get a clear understanding of how all this works. So the first thing I'll do is I'll just take this off the top. I'll take this apart first. So when it is screw cutting, it's moving this along here. So if we take that right out, again, this is nicely scraped in here where it has to be, and that screw there affects the amount that this can be moved out or in, and that's affected by controlled by that screw there. So if I take this little bolt out of here, that's that pin. I think that's a very clever piece of machining and scraping. It's very difficult, must be very difficult to make accurately that. And one thing that's worth noting is that there's a number stamped on there. There's corresponding numbers in the rest of this, which ensure that they're all assembled from the correctly mated parts. But you can see this has had no use at all worth speaking of. I haven't quite fathomed out yet what this bit does. And the instructions that say in the manual are absolutely hopeless. There's no information at all. And you can see there the name is stamped on the casting there. This doesn't appear to be scraped on here, but there's some funny lines on there. I don't know where they've come from. Again, perfect condition inside. And I did wonder with this as to whether I finally managed to figure out how this works. And these two screws, as I mentioned, adjust for different slopes. But you can see it probably quite easily on here. Yeah, that should be visible. So this slide I've just left loose. So as I push this along, you can see this closing up and moving. So if I just apply pressure, as I move it back the other way, it's moving in and out about 2 millimeters, I suppose. over that length, and that's with that screw fully adjusted inwards. If I do it fully outwards, there's no movement at all. So for normal use, when you're cutting parallel threads, I'd have finally solved the problem, and why this bit seemed a bit unusual, couldn't figure out quite how it was working. Actually what's happened is that has snapped at that point on that casting. That's not a separate piece that's moved separately, or shouldn't be, it's just one piece. And it pivots about this screw here, so it's that way and that way. Well, I don't think I'm going to bother making another piece. I could make a bit to replace this where it's snapped, but I think I won't bother because I'm not going to be using tapered threads. I'll just leave it in there so it's got all the original parts. And make sure that that's not going to bind on anything. Put that back together.